In this video, we're going to take a look at the changes to the absolute value parent function that different changes to the parent function's equation has on the graph. Here we have the parent function of the absolute value equation graph. Notice it makes a V shape, and that's our basic shape that we always start from. So let's just start taking a look at a few transformations and what they do. We'll begin with this equation. Y is equal to the absolute value of x plus 3. Notice that this time plus 3 is added inside the absolute value. We call that inside the function. And whenever something is added on the inside, it actually has the effect of moving the function that many places to the left. Addition is left, subtraction then would be right. So in this case, we would start with our vertex right here, and we would move it to the left 3 places, and then we would still just do the same pattern of up 1 over 1 using just like a slope of a line here to draw that basic pattern like that, and then we would just reflect that pattern that direction. Might be off just a little bit, but something like that. If we were to put the plus 3 here, it's on the outside of the function, outside of the absolute value sign. This has the effect of moving the graph up 3. If it were minus 3, it would move it down. So our new vertex this time would be here at plus 3 on y, and again it would still have that same slope, if you will, of 1, and over here basically a slope of negative 1. So it looks something like that as I sketch it. And again, my graph won't be perfect, but it's the same shape, but it's all been moved up by 3. If we had had minus 3, then it would have been down 3. So those two transformations are fairly straightforward when we do those. Let's look at this one. If you put a negative in front of the absolute value, the negative has the effect of reflecting the whole graph over the x-axis, or turning it upside down. So this time we still have the same vertex. It didn't move. It would be at the origin at 0, 0. But the graph now would open down like this, and we'd have a graph that looked like that. So our parent function would in effect be turned upside down. When we start to put numbers in front that are multiplied on the outside, like this is a 2, this is actually called a vertical stretch of 2. And the 2 actually affects the y-axis. Now I like to think of it like this. If you put 2 over 1 like this, we could do the reciprocal of 2 over 1, which is 1. And this would tell me how much x went over, and this would tell me how much y went up compared to what it would normally go up. So x would go over 1, now y goes up 2. It normally would go up 1. When x goes up over 2, 1 more, y would normally go up 2. It goes up twice that far, so it goes up 4. So we get a graph that starts in the same place, but it's a much steeper graph. It's actually, opening is only half as wide, and it reflects again across the y-axis, something like that. So it is a vertical stretch. If that number is greater than 1, it will be a stretch, but if that number is between 0 and 1, a fraction, such as 1/2, now it's called a vertical compression. Again, if I think of the reciprocal of 1/2, 2 over 1, remember that means that for however far it goes over for x, it goes up 1 time for y as far. So every time it goes over 2, it goes up 1, and over 2 more, up 1 more. So we get this. It's called a vertical compression. If you look at the graph, draw this side. Not a great drawing, but you can see the idea. If you look at the graph, it looks like it's been pushed down from above. It's like you pressed on it from this direction, and it's compressed. That's why we call it a vertical compression. And then we can also put those numbers inside the absolute values, or inside the function, and this has the effect of being a horizontal compression, which actually with an absolute value is pretty much the same thing as a vertical stretch. We still can write this 2 over 1, flip it over, and realize that that means that it goes, for every 1 it goes over on x, it goes up 2. So it does this. Notice it looks just like a vertical stretch in this equation. But this time we have actually a horizontal compression. It's being pushed in this way, even though it looks like the vertical stretch of 2. Same thing is true if we do a 1/2 right there. Excuse me, let's do this one. If we do a 1/2 right there, this is actually a vertical, or rather a horizontal stretch of 2. Again, we'll just take this number in front of x and do its reciprocal. And what that tells me is that from x it goes over 2 and goes up 1 like this. So it is horizontally being stretched out. Again, it has the same effect as a vertical compression. So in an absolute value function, because basically you have a line on one side with a slope of 1 and a line on the other side with a slope of -1, it doesn't really make any difference where you put that number inside or outside. It has the same basic effect on the graph itself. So this is the effect that different things have. What if we put several together like this? So the effect we would have here is the first negative that we see in front would have the effect of reflecting, and it would reflect over x. The second thing we see is the 3. That would be a vertical, I'll abbreviate, vertical stretch of 3. And then the -2 here on the inside would have the effect of moving it to the right 2. Remember, minus on the inside moves right, and minus on the, or plus on the inside moves left. And then finally this +4 out here would move up 4. So this one actually has 4 transformations that are going to take place. Let me erase these and I'll draw the graph for you. So we reflect over x. We first need to establish our vertex. So we'll use the 2 things I have underlined first. -2 is move 2 to the right, and +4 means I'm going to move up 4. So here's my new vertex right here. So that'd be right 2, up 4. And then I'm going to be opening down, and notice that my vertical stretch is 3, which means for every time I go over 1 on x, I'm going to go not up, but down 3 this time. So I'm going to go over 1, down 1, 2, 3, over 1 more, down 1, 2, 3 more. And so we get I think I went 1 too far. Get it right here. We get a vertical stretch, only going downward this time. Having trouble drawing here. And we would reflect that the same way the other direction. So we go over 1, down 1, 2, 3 here also. So it looks something like that. I might have missed it a little bit. But it is a vertical stretch of 3, reflected over x because of the negative in front, moved to the right 2, moved up 4, and the graph would look something like that. So we're able to graph it from the shape of the parent function just by knowing the effect of each of those numbers and positive and negatives on the original equation itself. So that's a little bit about transformations of absolute values. I have other lessons on transformations in general with other parent functions. They're all on my website at MyMathEducation.com, and there are many other lessons there as well on different algebra topics that you can go take a look at. Thanks for watching this video, and hope you'll come back for other videos on algebra topics. Thanks again.